All right, we'll go with that. That is bright. Cool. So let's see. Any questions before we start? Yeah, it's good if the quit button works on either player's turn. It's a little tricky sometimes shutting down networked connections. And so I would like the quit button to work reasonably well, um, where you can hit the quit button and the thing will shut down. But it can be a little tricky, so don't get too bogged down on it. If something weird happens, like you hit the quit button but it doesn't acknowledge it until the other player makes a move or something, that's fairly forgivable. But yeah, it should mostly work like that. Let's see how to start PA5. Yeah, start with PA4. That's a good answer. Could you explain how to use threads in the context of PA5? You use a thread to do all of your networking. The reason being that if your main the swing is event-driven code, right? So when we're running our GUI in PA4, your code is not running most of the time. There's no while loop that's running constantly checking something, right? So how are you going to wait for a mouse click to come in from the other player? If you don't use a thread, your only option would be somewhere, like maybe after you make a move, you're going to go into an infinite loop where you wait for, input to come in through the scanner. Well, you can't do that with swing. That's going to freeze your GUI. And if someone tried to click a button or resize the frame or something like that, it's not going to work. So if we're going to have something like, while sc.hasNextLine, that's just got to go in a separate thread so that swing can continue the way it normally does. So that's basically why we're using threads. When starting threads for sockets, should the accept method also be contained within the thread? Probably. But doesn't necessarily have to. But I just kind of think putting everything in like a separate class is going to make the most sense. But there's other ways to do it. Telnet connection hasn't been working a little. Can you explain how to read an input from the get output stream and the get input stream? Telnet connection hasn't been working a little. I'm not sure what the details of that are. But I'm planning today to basically go through like a start to finish example of doing a client server model with a thread to do two-way communication, and this may help with some of these more general questions, because this will definitely use input stream, output stream, and some threading. So we'll do that. All right, so I've been trying to get an established connection. It hasn't been working most of the time when creating a server socket and trying to connect using the accept method. That should work. How are you trying to connect to it? Are you using your own code, or are you trying to use Telnet? Or Putty or something like that. So if you make a server socket and then you say accept, then your Java code should hang in that call to accept until someone tries to connect to it. And at that point, if you go out to Telnet or Putty or something and try to connect to that port on that machine, then the call to accept in your Java program should come back and your Java code should continue. If you're on one machine, this should work fine. If somebody from another machine tries to get to your socket, that's not going to work unless you do port forwarding or the dreaded DMZ or something like that. But on one machine, none of that should be necessary. You may get some pushback if you have Windows. Its firewall may get excited and say, you know, someone's trying to connect to a port, but you just have to tell it to allow that. Just to confirm, in your initial example for setting up socket, the server and client classes each had a main function. In case of PF5, there should only be one main. Yeah, there's only one main in NetDots. And you probably only need one net thread, but you know, you can have different methods depending on whether you're the server or the client. You can use a flag, you can pass arguments. It's up to you how you want to design it. But you know, some things that you need to do will be the same for a client and server, such as, you know, getting a XY pair and calling your click code. Some will be different. For example, creating a server socket versus a socket, doing an accept versus constructing to connect, and so on. Definitely make your netThread class separate. If you want it to be a thread, it's got to extend thread, so put that in its own class. And then, since you've got a class that's doing network stuff, right, you can put all of your network stuff in there. Whether it needs to actually run in a thread or not, it you know, logically collects it into one spot. And you know, if you construct a server in your, you know, create server method, you've got the server socket right there in the class. You can save it as a variable and access it and so on. And we'll see that today also. All right, so before we spin into all that, let's touch base on the SLP. So two reminders. First of all, your SLP final upload is due a week from yesterday, 8 a.m. Okay, June 7th, 8 a.m. That's a hard deadline. So please don't email it to me, you know, at 10 o'clock in the morning and say, here it is. It's got to be in by 8, right? So whatever you have, you know, submit it before then. And you can submit what you have right now, and then if you get abducted by aliens Monday morning, I'll still have, you know, your SLP report as you had it today. So you can submit multiple times. I'll take the latest one that's submitted. And look at the requirements, okay? So most important thing, don't turn in a one-pager. So let me just show you as an example. One student's SLP report from a couple of years ago. So this person was using a machine learning system to try to implement a self-driving car algorithm. So you know, there's an abstract. Here's some background on the machine learning system. Some example runs, and he was embellishing this machine learning system. And then a pseudocode for how the system's going to drive the car. A discussion of, you know, other approaches to using machine learning to do this kind of task, so alternate solutions, and then the solution that the student came up with. So here's a high-level synopsis of it. Discussion of the car itself, the project setup. So he's running this in, I think, Unreal. And you know, there's screenshots, there's links to other resources on Google Drives. There's a GitLab repo later on. There's code included in here. There's you know, output results and so on and so forth. And then you know, here's git link to all the code that was developed. And a discussion of how well it worked. So the different tests that were run. Here's pseudocode for the algorithm that he actually implemented. Here's some information on what he had to do to get this running on his Linux system, right? So this is the whole shebang, right? Start to finish. Tell somebody, you know, what they did. And in this case, this student was actually working on a research project that I was interested in, and so I had sort of helped him with it. And so this is actually going to be published in a few months as an appendix in a book that I'm putting out on Amazon. So you know, that's what we're looking for basically, right? As much detail as you think is appropriate to describe what you've been doing for, you know, in our cases 2 quarters. In other cases, this would be an entire 3 quarters worth of work. And what you don't want to do is print this out and add a sentence after each of these. And I will get some of those from people. But that's would be what you would do if this was a homework assignment, right? This is a technical report. So think of it in terms of, if somebody read this, would they know everything that I had been doing for the past 2 quarters, 20 some weeks worth of effort on this project? Even if you haven't been working for 20 weeks solid, right? I understand we work on this in the beginning and the end of the quarter usually, but that kind of timeline of effort. And just, put in what you've been doing, what's happened. If you set off to do this and you ended up doing this, that's okay, right? But why did you do this and not get to that, right? What were the obstacles that you ran into? What did you learn as a result of running into those obstacles, right? All of that is fair game for there, and there's different sections on there. Lessons learned can be a big section in terms of, well, I wanted to implement such and such, but I quickly found out this and that and this other thing, and so I had to scale back, and so on and so forth. So don't worry about, I said I was going to do this and instead I did that, right? Don't let that stop you from writing, a report that spells out your efforts and results and so on. Just, share the results of this. It's a learning process. So the presentation is also Monday, and it's going to be at 10 o'clock, so during class time. It will be a different Zoom room, and I'll have information coming out in a few days with the Zoom information for that. Got to go to the presentation, okay, to get the presentation points. And it'll be 10 o'clock to 11 o'clock that same Monday, so a week from yesterday. And it will be like it was before, so there'll be breakout rooms. You'll have an assigned room. You'll go into the breakout room, and then visitors, guests will just come around and go from room to room and hop in and listen to your pitch. And you can just sort of take turns in the room with whoever else is in there with you, going through your presentation, and people will come and go. All right, any questions about SLP? Cool. And again, it's pretty low key, I mean, it's a low key opportunity to do something that you'll do a fair amount in your careers, which is, talking to people about what you've been working on. And this is always a friendly crowd, and it's supportive and so on and so forth. So have fun with it, right? If you've been working on something that you enjoyed working on or enjoy talking about or thinking about, then that can be a lot of fun. Yeah, get some Red Bull and yeah, I would dig having Crab Rave play. That's an awesome shot. Alright, I don't know why I'm green. Well, that just blinds me and makes me green. Alright, so let's talk about server client plus threads. I don't know how far we'll get here, but we can continue tomorrow. Alright, so we got server, client, and thread. So here's the plan. Let's write some code. Let's have a server and a client. And same setup as before. Let's have the server start first and have the client connect to the server, and then let's set up two-way communication. And the two-way communication is going to require us to use a thread because we want the server to be able to read from standard in and send to the client. But at any time, if the client sends something to the server, we want to see what the client sent. So we're going to have a pair of threads for doing this two-way communication. And I'm going to do this from the command line, which I'll probably regret because I'm going to have to keep importing stuff. But we'll see how this goes. All right, so let's see. So let's start off with a server socket and wait for a connection. Alright, we're going to repeat this code a lot. Is it Typo Tuesday? It could be. So we'll create a server socket on port 1234. And let's go ahead and accept a connection. Okay, so if we get to this point, we've got a socket, right? So let's see, in PA5, this would probably be in, you could do this in the constructor for the net thread, if you wanted, which you would construct when you hit the start button. So on the server side, you type in your name, all that kind of stuff, then you hit the start button, and that creates the server socket that listens. So you would want to run this code in response to clicking the start button. Where would you do that? I would probably do it inside the net thread. So maybe when you click the start button, construct the net thread object. Go ahead and do this, and then maybe call the start method, which will execute the run code in the thread. Alright, so socket is now available. So let's make a pair of threads. For communicating with the client. So, my thread 2 equals new my thread. And I'm going to send the socket to the constructor of a my thread. Alright, and so I'm going to create a thread called 2, and this is for sending to the other side, which for us is the client. And I'm going to make a thread called from, which is for receiving from the other side, which is the client. So I'm going to make a thread called to and a thread called from. And on the client side, I'm going to have a thread called to and a thread called from. And so the to process is going to basically read standard in, send to the socket. And the from process is going to read the socket and then send to standard out. So a pair of threads. And this may not work first try, by the way. It's my usual disclaimer. Just lost my chat window. Hold on. Alright, we're back. Alright, so I got a pair of threads, and I'm going to say, let's start those. Now, at this point, my main thread has nothing else to do. So I'm just going to print a message saying the main thread is done, and I'm going to return. In a different setting, what I might do is go back up here to the top and accept another connection, and then create a pair of threads, and so on and so forth. So in PA5, right, our main thread's going to create, we just need one thread to handle the networked communications, and then whatever is creating that, you know, the code that handles the start button, for example, we'll just go ahead and return. But we have a thread hanging out there that's sitting back and doing I/O on the socket. So yeah, if we wanted to be able to accept another connection, then yeah, we could put this whole thing in a while loop. But we don't have to do that, and we don't want to do that in PA5. Right, we're going to run the server once. One client is going to say connect. We're going to accept that one connection. We're going to play the game, and then we're exiting completely. So don't put this inside a loop in PA5. It's adding a lot of complication. All right, so let's make the myThread class. And so we need a constructor. All right, so we'll pass a socket to the constructor. We'll save it in this variable up here, and let's go ahead and make a PrintWriter. So this is for reading from the socket, and this is for writing to the socket. So, PW is new PrintWriter. Let's see, so we want to print to a PrintWriter. The landscapers are back outside, so we'll be hearing them for a while. All right, so we construct the socket. We've got a PrintWriter and we've got a scanner. And let's see, I need something else in here. So I need to tell the thread whether it's supposed to be sending to or from. Okay, there you go. Yeah, you need both. Alright, so I'm going to pass a flag to my constructor which says, am I the to thread or the from thread? So the to thread, I'm going to pass a flag of true, and the from thread, I'm going to pass a flag of false. And this argument I'm thinking of as am I sending to? Like I say, this may or may not work. So we'll have a to flag. Alright, so depending on whether we're sending to or from, we need either a scanner or a client. So let's see. And this is where things start to get a little wiggly. So if we're the to thread, then we're going to read from standard in and we're going to send to the socket. So we need a PrintWriter. If we're the from thread, we're going to read from the socket, which is a scanner. So let me do this. So if to flag we'll go ahead and we'll construct either PrintWriter or the scanner. And now we'll do our thing. So if we're the to flag, and this is one of these rare cases where I'm going to put a bunch of code inside an if statement. So if we're the to flag, read from standard in, send to the socket. So let's do let's make a scanner on system.in. We'll call that standard in. And while we have more stuff available, we'll read the next line from standard in and we'll feed that to the PrintWriter. And we'll go ahead and flush the output. And when we're done with that, we'll just go ahead and clean up and return. Okay, otherwise the to flag is false, so our job here is to be the from thread, and so we're going to read from the socket and send to standard out. So while the scanner has a next line, we will go ahead and print sc.nextLine. Alright, so that's the end of our thread. And what do we want to do in this cleanup method? I'm going to be lazy here. I'm just going to close. Well, I can't be lazy. I'm not going to bother cleaning up. All right. So, this is the constructor. We'll go ahead and make those things. Okay, so we need a run method. So we're going to make a run method to do all of this stuff, right? So we'll construct the thread, which will create either a PrintWriter or a scanner based on the socket. And then when we call the start method, that will create a new thread, execute the run method, which will go ahead and start the loop that either reads from standard in, sends to the socket, or reads from the socket, sends to standard out. And so on the main program, right, just looking at the server side, but the client side will look almost exactly the same. On the main program, we'll go ahead, we'll make a pair of threads, one to be a to, one to be a from. We'll start them both, and then we're just going to exit. And then the hardest part of all of this is we got to put in about 1 billion imports. So that may be all we need there. Server socket and socket, but then over here, what else do we need? We got PrintWriter, we got a scanner. We're going to need socket. Anything else? All right. I have no idea what's going to happen when we run this. Yeah, that's not bad. Scary. Usually when you just have something like a simple syntax error, you fix that and then you get like 80 billion errors because it can now like criticize you properly. But okay, so we lucked out here. So let's go ahead and start that. And let's go into a new window over here. Social D agrees. So let's go over to 1234. So the main thread is already exited. This is the client. Hello. Cool. And can we type here? And yeah, when we type over here, it also comes out. Right, so we've got full duplex communication going here. We can type over here. We can type over here. We can be part way through typing, and if a message comes in from the client, it appears, and then if we come back over here and we hit enter, our message gets sent, and so on. So in our main program exited, but we've still got 2 threads going, right? One for each way of communication. Now you don't need that for for PA5 because we don't have to be prepared to receive a message at any old time, right? We have this taking turns between the client and the server. Server sends their name, client sends their name. Server sends XY, client sends XY, server sends XY, client sends XY, and at any point somebody might send quit, and then both sides shut down. So we only need one thread that we create, which is this thing we keep calling net thread, but it looks basically like that. Now I did a horrible thing here. I did not close out my connections by closing the scanner and PrintWriter and socket, but I'm not worried about it. So on the client side, it's almost exactly the same. So let's just develop the client side instead of using Telnet. And the only difference is the client does not use a server socket. It simply creates a socket. And once we create this socket that should connect to the socket on the server side, all of this should be the same. When we create the to thread, that will still read from standard in and send to the socket, and so on and so forth. So over here we run the server. Over here we'll run the client. Hello, 1, 2, 3, 4, 5, 6. There we go. And if I control D over here on the client side, that should close it out, but it doesn't. So the shutdown is different. But we did stop sending, but we're still receiving. So these are weird things that you may encounter. What about on the server side? If I hit Control D, now it's no longer sending. But these did not exit. Interesting. To flag. Ah, okay, right. Yeah, so we have a thread which is reading from the socket, and if that thread doesn't exit, then we won't come back to our command line prompt. Right? And this thread is not exiting because the socket's not being closed. So if we wanted to worry about cleaning this up, we need to do some things in here. So let's see if we can make that happen. I don't know if I can do this without a try-catch block. Yeah, I can do that. We may also have to close the socket. Alright, so if I Control D over here, now this has exited. And over here, it's still running, but what I type is not going anywhere. And so this is a trickier problem when you write something like a terminal program, should not be a problem for PA5, because PA5, you're not just going to quit, you're going to actually send a quit message. And so in your code that's normally picking up XY coordinates, before you take what you receive and break it into XY coordinates and call your click code, just check to see if it's equal to quit. Right? Remember, don't use equal equal, use dot equals. And if it is, then go ahead and close out the connection on that side. So that's an example, right? With some overlap to PA5, but the basic structure was, I had a constructor that did things like save the socket that we're using, save some other information, which for you might be, am I the client or the server, or you could make separate threads for each. And then a run method, which is what's going to actually happen once you want the thread to start executing in its own context. And that's usually after you've decided the game has started. You can go ahead and start your run method. Let's see, I got an illegal state exception when closing PrintWriter and scanner when I get a quit message. Interesting. Illegal state. That's interesting. Make sure that the scanner and PrintWriter exist and that you're not quitting before they've been constructed. Or maybe initialize them to null and make sure they're not null before you try to close them. Yeah, I don't know what else would cause that. That's a good office hour thing to look at, though. Attempting to perform search after the scanner has been closed. So, or it could be that you're closing it and it's already been closed, which might be an illegal state. Or if that error's coming, does that make sense? Yeah, I think that state corresponds to you've closed the scanner and now you're trying to do something as if it was still open. To see if maybe it's closed twice. Man, it's weird. I see myself on here and I'm kind of like green and dark and I feel sleepy looking at myself. Kind of weird. Not making sense asking office hours. Okay, yeah, come by. We can look at your code. All right, other questions about this or about net threading? So it's not super duper critical where you construct this, but you want to, on the server side, open a server socket after the person running the program says connect, and start listening for connections after that. Start listening for messages after that, and for the names, right? You move together with one exception, which is the name exchange. And the name exchange, you can add that on at the end, but it's a good kind of first thing to get working. So on the server side, I would suggest, accept a connection, send my name, receive their name. On the client side, you're going to connect to the server socket and then receive their name and send my name. All right, it may be a little easier to do that in that order. Because if you both try to receive the other player's name first, you're going to get stuck in that receive call, and neither of you is going to proceed to the send call, and you're going to be deadlocked. right? So you can get around that by hardwiring, since you have, you know, a distinct identity for the server and client. You can just decide, well, server will send first and client will receive first. And then after that, it's the same thing. When you get a mouse click and it's your turn, send those, you know, to the other side. When you receive a message from the other side, it should be a legal mouse click. You go ahead and call your code. How do we make the connection outside of our own personal network at home? So that's trickier. So you need to get into port forwarding, which we probably can't do in 2.5 minutes. But if you go into your router settings, you'll find usually under network or security a section that talks about port forwarding. And the basic setup is, you know, you've got your local area network, where your addresses are typically something like 192.168 something, and these are all connected to your router. And so your different machines can talk to each other through the router, and there's usually one connection out here to the internet, and it's got some, you know, mystical address that comes from your internet service provider, and this changes over time. So if somebody outside wants to connect to port, you know, 1234 on this machine, which is 192.168.0, you know, 25 or whatever, what you can do is inside your router you can say, hey, if you get any requests for port 1234, send them to this machine. And now if somebody tries to connect to this machine, port 1234, this address gets them to your router. Your router says, oh, port 1234, that should go to this machine. It'll take those incoming packets and forward them to port 1234 on this target machine. So that's port forwarding that's set up. And you know, it's a bit of a security exposure, because now there is a pathway for somebody outside your local net to send information to one of your machines. Is it a big security issue? Probably not. But, you know, if you were running code here that had, you know, a buffer overrun capability and somebody knew what you were running here, theoretically somebody could send in, you know, a big set of information that would overflow your buffer, generate code that could be executed on here, and maybe use that to, you know, sniff packets on your local address, look at network traffic, things like that. Practically speaking, not really a big issue, but just something to be aware of. So normally, you know, anybody who tries to get to your router can get to your router, but they have no access to these machines because they're, you know, these local IP addresses. If I try to go to 192.168.0.25, the connection of routers out there in the universe is not going to send me to your machine with that address. It's going to send me, you know, probably nowhere. So that lets you set that up. Let's see. I missed some messages. I use system exit to close the JFrame when I quit the game. Yeah, that's a good way to do it. That will get you out. You can, yeah, that's good. Let's see, if you have Comcast, they make you do it through their site. Do they? Oh, no, you don't have to do that. And if you want to be extra secure, you can put your own router in between Comcast's modem and your local network. Something reset my modem once, and it put it back to a default password, which really kind of squeaked me out. So I have my own router. Here's Comcast's modem. Here's my router, and then here's my local network. So I can do port forwarding in there. Yeah, unless you use your own router, exactly. All right, cool. We are out of time. Cool, good. Hopefully that helped some. Keep working on it. Come by office hours if you want, and I will see you next time.